So in this video, we are going to solve quadratic equations by using a technique called completing the square. We're going to learn this because it's going to tell us how an important formula is obtained, which is a quadratic formula, and we're going to use this later on maybe to graph parabolas in a different way. So we're going to solve the equation x squared plus 4x equals -1. Okay, now I'll show you maybe two ways of trying to solve that problem. First thing that comes to mind is, well, this looks like a quadratic equation. So I'm going to make everything equal to 0 and I'm going to try to factor this. Now using our factoring techniques, I'm looking for a product of 1 and a sum of 4, and very quickly I'm stuck, right? Because product of 1 means it's 1 and 1, minus 1 or minus 1, and clearly that does not add up to 4, so we're stuck here. So this solution just dies right there. Okay. Solution 2. Okay. We're going to say, all right, here's what the idea behind solution 2. Okay. We're going to try to add something here. Okay, so that the left-hand side becomes something squared. Okay. If we add it on one side, we need to add it on the other side so that everything stays equal. So on this side, we'll have this. And here, this expression is going to be x plus something squared. Once we have the left-hand side written as a perfect square, we're going to take square roots on both sides. And on the other side, well, you know, it's going, if I said we're going to take square roots, but the other side could be the positive or the negative square root, right? If I've got if I write down like x squared equals 9, where x could be plus or minus the square root of 9, right? So we're going to do the same thing here. If I have something squared, well, that something squared, which is x plus question mark, is going to be plus or minus -1 plus that thing we added on the first line. And finally, we're going to subtract whatever we have here. We're going to send it on the other side. So we're going to have this. Okay. So that's the idea, and then we'll have solved this expression for x. So, but the big question is, what do we had here? Okay, all right. So let's backtrack. Okay. So we're going to add what? I need to make the expression a perfect square. Now, where does that come from? Perfect square, or completing the, or actually we call also this step completing the square. Sure, where that comes from. It really comes from completing a square. Imagine x being a positive quantity. So x squared is a little square. That's x by x. Okay. Now I'm going to add 4x to it, but I'm going to add 4x in a kind of interesting way. I'm going to add a rectangle here. That's, this side is x, right? Because the same side is this. And I need to add 4x. I want to add two identical rectangles like this, okay, with side x. So if they add, if they both, this and this add to 4x, this would be 2x and this would be 2x, right? And this guy is x squared. The area is x squared, right? So this side here would be 2 and this side here would be 2. 2 as in, I took the 4 and I divided by 2. Okay, so let's maybe remind ourselves that this is how we got that little 2 here. 4 divided by 2. Okay, is that side. And same thing here. 4 divided by 2. That's how we got that side. So to complete the square, I want to make the entire thing here, the sum of all the areas, a square. So if I want to make this a square, notice that it's the length of one side here is x plus 2, right? This is x plus 2. And so is this, x plus 2. So it is really a square. So what's the area that's missing? What do I need to add to so that when I add x squared and 2x and 2x and that other expression I'm looking for, this is the double question mark above, what should that be so that it's so that when I add the errors it becomes a square? Well, that square I'm looking for, it's 2x by 2x, isn't it? So this is going to be 4x squared. So that's what I need to, sorry, let's backtrack. It's not 2x by 2x, it's 2 by 2. Aha, so it's 2, yeah, this is 2, right? 2, and this is 2. So this is 2 and 2. So 4. 4 is what I'm looking for. Okay, let's backtrack. X squared plus 4x, I'm going to add 4. And if I add 4 to it, this now will become x plus 2 squared. You can check if you expand x plus 2 squared, you're going to get x squared plus 4x plus 4. But above, you have the geometric demonstration of that result. So on the other side, I've got minus 1. Right, so I'm at this step, right? So on the other side, I need to add 4 on both sides because on one side it makes the expression a perfect square, and the other side is just to keep things equal. So x plus 2 squared is 3. Okay, and as I told you, we're going to take square roots on both sides. Okay, if I take the square root on both sides, I need to consider the positive and the negative square root. I solve for x. And I basically get two solutions. I get x is either minus 2 plus square root of 3, or x is minus 2 minus square root of 3. Okay? And in terms of the graph of the curve related to that equation, what's the equation again? It's x squared plus 4x equals minus 1. So that will be x squared plus 4x plus 1. So x squared plus 4x plus 1 would have minus 2 plus or minus root of 3 as its x-intercepts. So you'd have two x-intercepts here and here. This would be minus 2 plus root of 3, and this would be minus 2 minus root of 3. And you have the curve is concave up because x squared has a positive coefficient in front of it, a coefficient of 1. And I can see that 1 here is the y-intercept. Okay. That's not the point here, but I thought I'd still show you that everything's related, right? So I can still obtain with the information, the answers obtain information on the graph of that curve. But I've used completion of the square to get my intercepts. So maybe let's look in general how we complete the square. So in general, if I've got x squared plus bx, okay, and I want to complete the square, so I want to add something to write this as a perfect square. So what do I need to add? Well, let's see. Let's look at x squared plus bx. Well, x squared is x, can be related to the area of a square that's x by x. Bx, I'm going to add two rectangles, okay, whose areas sum up to bx. So that has to be of length b over 2, and so is this, b over 2, so that the area of this guy here is b over 2 times x. This is b over 2 times x, so b over 2 times x plus b over 2 times x is going to give us our bx. And to complete the square, the term I'm looking for, its area is the area of the square that's b over 2 times b over 2. So this is going to be b over 2 squared. So this is what I'm looking for here. The expression I'm looking for is b over 2 squared. And that's going to give me, well, it's going to give me a square, right? That's b over 2, not b over 2, but x plus b over 2 times x plus b over 2. So that's is x plus b over 2 squared, like this. Okay? And it works, so here we've sort of pretended that the b is a positive because it helps us understand the problem in terms of areas of rectangles, but it also works if you've got, let's say if you've got minus b here, let's say b is positive and so minus b would be negative. If you've got x squared minus bx, if you add to it b over 2 squared, you're going to complete the square. You're going to get x minus b over 2 squared. So you can verify this algebraically. It works. Okay, so I'll just finish by using that formula to complete the squares of different expression. So let's say A, I've got x squared plus 3x. Okay, I'm going to try to complete the square. So I'm going to add something to 3x so that it becomes a perfect square. So this is my b here, right? So what I need to add here is b over 2. So I need to add, well, actually I need to add b over 2 squared. So I need to add b 3/2 squared. Okay. Now to make this work, right, I've added 3/2 squared, so I'm going to subtract 3/2 squared just to make the this equation valid. Otherwise, right, if I don't put this, I've added something on the right hand side and it's not equal anymore. So I'm just going to subtract it like that to make it equal. But what what I'm interested in is getting these terms written as a perfect square. So this is x plus 3/2 squared minus 3/2 squared, like that. Okay, so I've completed the square here. Let's do another one. Oh, actually, you could expand the last term. I didn't do that, but obviously you can do that. You can write minus 9/4. Let's do another one. 2x squared minus 7x. The difficulty here is the 2. Right? Everything I told you about before works if the little square, right, this one, right, is x by x, but here it's 2x squared, so it doesn't work anymore. So do I need to put 2 squares next to one another? No, we're not going to do that. Here's what we're going to do. The first step we're going to do is we're going to take out that 2, so we're going to factor it. Okay. So what we're going to do is complete the square of these two expressions. Okay. So now our b is 7 over x. Now it's minus 7 over x, okay, but let's worry about that afterwards. So b is 7 over x, so not 7 over x, 7 over 2 times x, sorry. So b is 7 over 2. So I need to add here b over 2 squared. So what is that going to be? That's going to be 7 over 7/2 divided by 2 is 7/4. So this is what I need to add here, okay? 7/4. So b over 2 squared, okay? And since I'm adding it, I need to subtract it immediately. It needs to be subtracted within the bracket, right? You can't put your bracket there because then now it's not equivalent because the 2 multiplies this, right? So you'd be adding 2 times 7/4 squared, but subtracting it only once. So you really want to make sure that that bracket ends here, so that you've added and subtracted the exact same number. Now, let's return to this. The first 3 terms, these form a perfect square. So this is x minus 7/2 squared. Minus because I had a minus here, right? So watch out for that. We're subtracting 49 over 16. Okay. We could leave it like that, or we could distribute the 2 just to finish it up. So we multiply 14 over 16 by 2, so we get 49. We get a 49 over 16, and we multiply that by 2, we get 49 over 8. Oh, just realized I made a small mistake. This is a 7/4 here, right? So it's b over 2 that you want to have here, right? So let me backtrack. See, it's b over 2. Okay, so If it's b over 2 squared, it's b over 2 you want to have here. Okay, so we're good, but everything else is okay. And maybe part C. No, I don't have part C, so I'll see you in the next video.